NASA scientists insist solar flares and storms to cause harm on whales and lead to serious animal bleaching. This report is from an anonymous astronaut. The solar storms that fling waves of charged particles toward the Earth may be to blame for the stranding events that leave whales dying on shore for unknown reasons. It's not a new hypothesis, but now researchers from NASA, the Bureau of Ocean Energy Management and the International Fund for Animal Welfare, I4, plan to combine datasets on these seemingly disparate events to see if a statistical link between solar flares and stranding events exists. If there's a connection, it's a discovery that could help to protect many species of endangered whales. Stellar rumblings. A solar event begins when fluctuations in the sun's magnetic field store and release tremendous amounts of energy in the form of a stream of charged particles. On Earth, the influx of electromagnetic activity can interfere with satellites, disrupt power grids and poses a risk to astronauts' health. The flares also warp Earth's magnetic field, temporarily altering the configuration of the geomagnetic contours that wrap around the planet. Here on Earth, whales are the planet's largest globetrotters, traversing the seas to reach seasonal spawning and feeding locations. How they stay on track on journeys of well over 1,000 miles is still unknown, but a popular theory holds that whales navigate with magnetoception, detecting Earth's magnetic field lines, to guide them toward their destination. Such an ability could come in handy when crossing thousands of miles of featureless ocean, but it would also leave the whales vulnerable to the periodic disruptions caused by solar storms. Whale strandings have been reported going as far back as ancient Greece, but biologists still struggle to explain why they happen. The whales could be sick or injured, fleeing predators or chasing prey. Perhaps the seafloor is too gradual to reflect sonar, leaving the whales blind to the approaching shore. Military sonar exercises and underwater explosions may damage whales' hearing and disrupt their navigation abilities. Connecting distant dots. Whatever the answer, it's unlikely that one single theory will explain these beaching events, says Antti Pulkkinen, a heliophysicist with NASA who is involved with the project. Researchers from Germany performed a similar study in 2009, which focused on sperm whale strandings in the North Sea, and found a statistical correlation between solar flares and beaching events. Pulkkinen and his collaborators helped to expand this methodology to include all whale species around the globe. Pulkkinen and company will compile datasets of both whale strandings and solar flares going back decades and put them through statistical algorithms to see if a possible link exists. The work is currently underway, and Pulkkinen says that they hope to submit a paper by September. They have already gathered much of the data, he says, and now must undertake the laborious process of sifting through it. If a correlation does emerge, it could give conservationists an edge in the fight to preserve endangered whale species. While some beaching events may be natural, they can nevertheless cause harm to populations of whales pushed to the brink by human activities. If we learn that solar activity is correlated to mass strandings, especially in the stranding hotspots around the world, we can basically develop an early warning system to alert when we are entering a period of likely mass stranding activity, says Katie Moore, an I4 program director and collaborator on the project. The I4 already utilizes physical barriers like boats and acoustic deterrents to guide wayward whales back to sea. Solar storm forecasting could give them a heads up a day or two in advance of the event, putting the I4 team on the lookout for confused whales headed for peril. According to a study by NASA scientists to see if whether solar storms cause animal beachings, NASA realized that a long-standing mystery among marine biologists is why otherwise healthy whales, dolphins, and porpoises, collectively known as cetaceans, end up getting stranded along coastal areas worldwide. Could severe solar storms, which affect Earth's magnetic fields, be confusing their internal compasses and causing them to lose their way? Although some have postulated this and other theories, no one has ever initiated a thorough study to determine whether a relationship exists, until now. NASA heliophysicist Antti Pulkkinen, who works at the agency's Goddard Space Flight Center in Greenbelt, Maryland, has teamed with the Federal Bureau of Ocean Energy Management, or BOEM, and the International Fund for Animal Welfare, or I4, to determine whether a link exists. Strandings occur around the world, involving as few as 3 to as many as several hundred animals per event. Although a global phenomenon, such strandings tend to happen more often in New Zealand, Australia, and Cape Cod, Massachusetts, said project collaborator Katie Moore, the director of I4's Global Animal Rescue Program. Headquartered in Yarmouth Port, Massachusetts, I4 operates in 40 countries, rescuing animals and promoting conservation to secure a safe habitat for wildlife. These locations share some key characteristics, such as the geography, gently sloping beaches, and fine-grained sediment, which we think all play some role in these events, she said. Skewed compasses. Another possibility is that these animals' internal compasses are somehow skewed by humans' use of multi-beam echo sounders and other sonar-type equipment used to map the seafloor or locate potential fishing sites, to name just a few applications. However, these human-made influences do not explain most of the strandings, said Pulkkinen, an expert in space weather and its effect on Earth. Theories as to the cause include magnetic anomalies and meteorological events, such as extreme tides during a new moon and coastal storms, which are thought to disorient the animals. It has been speculated that due to the possible magnetic field sensing used by these animals to navigate, magnetic anomalies could be at least partially responsible. Indeed, magnetic anomaly is caused when the sun's corona ejects gigantic bubbles of charged particles out into the solar system, can cause problems for Earth-orbiting satellites and power grids when they slam into Earth's protective magnetosphere. It's possible they could affect animals, as well, Pulkkinen said. The type of data that Antti has accumulated, together with the extensive stranding data at our disposal, will allow us to undertake the first rigorous analysis to test possible links between cetacean mass strandings and space weather phenomena, said Desiree Reeb, a marine biologist at BOEM's headquarters in Sterling, Virginia. Reeb approached Pulkkinen about launching a research effort after hearing his presentation about space weather in June 2015. Massive data mining effort. With funding from BOEM and NASA's Science Innovation Fund, Pulkkinen and his collaborators are carrying out a massive data mining operation. The team will analyze NASA's large space weather databases, including field recordings and space observations, and stranding data gathered by BOEM and I4. We estimate that records on the order of hundreds of cetacean mass strandings will be available for study, thus making our analyses statistically significant, Pulkkinen said. We therefore expect that we will be able to reliably test the hypothesis. So far, there has been very little quantitative research, just a lot of speculation, Pulkkinen continued. What we're going to do is throw cold, hard data at this. It's a long-standing mystery and it's important that we figure out what's going on. The team expects to complete the study by the end of September and publish its findings in a scientific, peer-reviewed journal. Should the study reveal a statistical correlation, team members said the results won't necessarily imply a causal link. However, it would provide the first thorough research into this hypothesis and offer the first step toward determining if it's correct. Save more animals. The results of this study will be informative for researchers, stranding network organizers, resource agencies and regulatory agencies, Reeb said. If we understand the relationship between the two, we may be able to use observations of solar storms as an early warning for potential strandings to occur, added Moore, who said she was immediately keen to get involved in the study. This would allow stranding responders in global hotspots, and really around the world, to be better prepared to respond, thus having the opportunity to save more animals.